We are Group N17, and this is our presentation for the third project for Engineering 3941.
I'm Cody Pike.
Dave Bauer.
And I'm Nicholas Pye. So in terms of what our presentation is going to be covering, we're going to do a quick overview of the history, modern-day applications, and future implications of the three topics that we chose for our report, which were the Internet of Things, Big Data, and Augmented Reality / Virtual Reality. We'll then be going through a conclusion of all the points that we've made throughout our presentation. One of the most prominent ideologies of everyday technology and in the history of human communication and interaction would be the Internet of Things, which is defined as a network of Internet-connected objects able to collect and exchange data using electronics. IoT devices are objects that can connect or disconnect from the Internet and can be remotely controlled in some manner and can communicate with other devices, which include and are not limited to automobiles, phones, and even refrigerators. Even though the publication of the Internet occurred in the 1980s, the actual concept of the IoT wasn't fully realized until 1999. However, the concept stems from both the creation of the Internet and communication of information, both of which were invented at different moments in history. The first form of information transfer was made through a telegraph in 1837 by Sir Samuel Morse, and the birth of the Internet began as a project known as ARPANET, also known as Advanced Research Projects Agency Network. These two elements would come together and pave the way for the multitude of IoT devices we have today. As well, it is noted that one of the earliest examples of an IoT device after the Internet commercialization was a cola machine that could connect to the Internet to let any local programmers know what drinks were available and if they were cold or not. Nowadays, IoT devices operate using multiple forms of communication as opposed to just the Internet. Even though the idea encompasses the Internet of Things, the concept still applies for devices that use other forms of communication between other devices, even though it's not through the Internet, such as Bluetooth, NFC, and sensors. In modern society today, IoT devices are used in a multitude of different industries due to their ability to network with very little CPU memory or power sources. Wearable IoT devices such as the Apple Watch or Samsung Gear are both able to track your heartbeat, check your emails, and tell you the current time while staying completely wireless through highly sensitive sensors. IoT devices are also present in the healthcare industry through a smart fluid management solution called EuroSense, which automatically measures the core body temperature and the filling level of the bladder. Given the current state of IoT devices on the market currently and their technological potential that is yet to be capped, the number of devices is only predicted to rise. It was determined that there is expected to be more than 24 billion IoT devices on Earth by 2020, which approximates to a little under 4 devices per person. More importantly, an estimated $6 billion will be invested into this industry, with a predicted $13 trillion profit being reached by 2025. With an increasing reliance for IoT devices that are connected, it begins to raise some questions and concerns for security and privacy in terms of how reliable or trustworthy these devices are. According to a Vormetric data threat report conducted in 2016, it was discovered that sensitive data protection was ranked at the top concern at 36% among those posed within multiple industries. An increased connectivity between devices can lead to more frequent and severe cyber attacks in the future through just about any medium, whether it be automobiles, homes, or personal devices. Hopefully, with the advancements that tech companies are making in their electronic security, these kinds of attacks can be averted.
Big data. Big data is an array of extremely large and complex datasets that can be studied or analyzed to find patterns or trends, and must be analyzed by means of computer software and specially developed algorithms. Big data can be used by manufacturers to track consumer trends, monitor equipment performance in the field, and improve the lifespan and performance of products. The history of big data is relatively new and brief. The first attempt to quantify the growth rate and the volume of data was made 70 years ago, known as the information explosion. Since then, papers related to data collecting, storage, and processing have greatly contributed to the boom of big data. In the diagram shown in the slide is a timeline of big data since 1997, which was the first publication of big data in the ACM library. Current applications of big data. In manufacturing, big data is used by manufacturers to improve productivity, durability, and supply chain feasibility. Manufacturers use radio frequency identification tags and smart sensors that collect massive quantities of data about themselves and their surroundings. Improving productivity using big data is accomplished by sensors on factory floors and equipment, which monitor the equipment itself as well as the surroundings. These sensors can also be placed on plant machinery as well as agricultural machines such as harvesters. The data from these sensors is analyzed and used to determine dynamic conditions such as conditions of the field, harvested crops, and adjustments of machine parameters. Big data is also used in manufacturing to improve quality of life and life cycle of products, as well as machines used in manufacturing processes by monitoring and analyzing data from beginning of life, middle of life, and end of life stages of a product's life cycle. The beginning of life cycle's main phases are production design and production marketing. During the production marketing phase, manufacturers try to figure out who their target customers are and what their needs are. In this stage, big data is used to find customer trends for production. The middle of life cycle for a product is a period which consists of utility, coordination, and maintenance. Analyzing big data in this stage makes it possible for manufacturers to find best means of product transportation and to even assist customers with maintenance through means of e-maintenance. The end of life cycle for a product is when the product becomes unusable or unwanted, and the only focus is on how to process obsolete products. During this phase, big data techniques can be applied to decide suitable end-of-life recovery options such as recycle, reuse, remanufacture, and disposal. Future implications of big data in manufacturing. The presence of big data in manufacturing is forever growing as the mass volume of data and information keeps growing. Data analysis allows manufacturers to make decisions on what products to produce and their target customers for those products, which is accomplished by data analysis from customer history, questionnaires, and browser history. The problem, however, with big data is that most companies do not know what to do with the data they have, let alone how to interpret them to improve their processes and products. They lack software and modeling systems to analyze data. Since the need for manufacturers to know, understand, and follow data trends from all stages of a product's life cycle, as well as all other information that allows them to manufacture and produce products better, there will always be a need for analysis of big data. Because of this, the influence of big data on the manufacturing world will continue to grow considerably in the future. However, manufacturing companies need to develop better ways of analyzing this data for big data techniques to work more effectively and to their full potential.
Augmented reality is a technology that allows computer-generated virtual imagery to be inserted into real-world environments in real time. AR is different from virtual reality in that VR, the user is inserted into completely artificial computer-generated environments and experience the space and surroundings as if they were real. With AR, the environment is real, but is advanced with virtual information and imagery provided by the technology. AR takes live, real-world environments and extends them to a virtual fantasy in a seamless way. Interactive AR and VR technologies were first introduced between 1965 and 1968 when Ian Sutherland and his team at Harvard University created a head-mounted display system. The term augmented reality wasn't coined until 1992 by employees at Boeing, who were using the technology to assist workers in an airplane factory by displaying wire-bundled assembly schematics on a see-through display. One of the first uses of a successful interactive VR device was in 1966, when the technology was implemented as a display system for pilots. For decades, VR would be used for learning and entertainment mediums, even though the term virtual reality wasn't coined until 1987 by James Lanier of the Visual Programming Lab. From here, VR trended towards a world of entertainment in the early 90s, being the main attraction point for virtual group arcade machines and in movie themes as seen as The Lawnmower Man. The cost of producing VR technology is continuously going down. Consumer demand for VR games and content is at an all-time high, and developing games is easier than ever given the developer kits distributed by Google, Valve, and other VR hardware companies. With the advances in technology, smartphones are powerful enough to render high-density displays and 3D graphics, making VR accessible to almost everyone. As well, large companies are aware of the VR demand and are heavily investing in the development of the technology. VR is used in many other implications outside of gaming. It is used worldwide for military training purposes by using flight simulation, medic training, and battlefield simulation. VR is also a very useful tool in the world of healthcare training purposes by simulating patient diagnosis, robotic surgery, therapy treatments, and dentistry. Today, AR has a variety of applications. It is a popular form of mobile gaming, integrating the visual and audio content with the user's environment in real time. Using features of a smartphone such as GPS, gyroscope, and the accelerometer, AR gaming became a worldwide phenomenon in 2016 with the release of Pokemon Go, developed by Niantic. AR is also used heavily by military pilots and has integrated the technology to display street names, airports, points of interest, and other land features in real time. The potential of future AR is limitless. As technology continues to advance, so will the ways augmented reality will be integrated into our lives. AR could eventually replace any screen we as a consumer use, such as television screens, e-readers, and handheld smartphones. Augmented reality could be the future of education and engineering, allowing its users to construct a design and interact with it in the real world before it is created. AR would render historical events, create 3D images from a textbook, or display anything as large as a galaxy to as small as an atom. It could be extremely useful in the classroom setting and would allow students to get a deeper understanding of the topic at hand. With newer technological advancements in development, VR aims to incorporate more senses than just the visual and sound components to create a more submersible environment for the consumer. Computer-generated sense and a wearable bodysuit will allow users to physically feel the environment around them and could potentially change the way our V is used entirely. VR not only changes the content we view, but how we as a consumer watch it. Development has already begun in sports entertainment, which would allow users to view sporting events from the best seats in the stadium right from their own living rooms. VR will continue to enhance learning capabilities as its participants in a variety of ways: classroom education, medical training, military and flight simulation, and countless other fields. By immersing the user in its content, they will better learn the material at hand.
In conclusion, Internet of Things wasn't invented until 1999. Modern devices use multiple modes of communication, and the potential for Internet of Things is limitless. Big data. Big data was first mentioned in a published paper 70 years ago. Big data is used by manufacturers to improve product life cycle and track consumer trends. The potential for big data in the manufacturing industry continues to grow as the mass volume of data grows itself. Augmented reality and virtual reality was first introduced in the 1960s. It is dominantly used for learning and entertaining purposes. Augmented reality is the future of electronics. That concludes our presentation. Thank you for listening.